Okay, so you should see question 1 on your screen. Okay, just give me 1 second. Okay, so let's start with question 1. So the question says, given f of x is equal to x squared plus 5x minus 14 over x plus 7, find the limit as x approaches negative 7 of f of x. So the first thing we have to do when evaluating limits is to plug in the value for x that the limit approaches. In this case, we have x approaching negative 7. So in our expression, we'll plug in negative 7 for every x in order to evaluate. So we have the limit as x approaches negative 7 of x approaches negative 7 of x squared plus 5x minus 14 all over x plus 7. So what we're doing is we're going to plug in negative 7 for each value of x. So instead of x squared, we'll have negative 7 squared plus 5 times negative 7 minus 14 all over negative 7 plus 7. So we'll do a quick calculation. Negative 7 squared is 49. 5 times negative 7 is negative 35. And we have a negative 14. So we'll do the quick calculation on top. 49 minus 35 minus 14. We should get 0. And negative 7 plus 7 is also 0. So what we notice in that plugging in negative 7, we get 0 over 0, which is an indeterminate form, meaning that we can't tell the value of this limit. If we were given 6 over 0, we can say that the limit goes to infinity or negative infinity. If we have 0 over 6, we can say that the limit is 0, but 0 over 0 is a special case. So moving forward, we'll have to manipulate the expression just a little bit to find our value. So I notice the numerator is factorable, so I'll factor that. So we'll have the limit as x approaches negative 7, and I'm factoring out the numerator, so we'll have x plus 7, x minus 2. We need to find those two numbers that multiply into negative 14 and add into positive 5. So the only two numbers that do that are positive 7 and negative 2. This is all under x plus 7. So I notice that x plus 7, we have an x plus 7 on top and an x plus 7 on the bottom, so those cancel. So what we're left with is a simplified version of the limit, which is limit as x approaches negative 7 of x minus 2. So we'll plug in negative 7 for negative 2 and evaluate. That gives us negative 7 minus 2, which is equal to negative 9. So that's our answer. So the limit as x approaches negative 7 of the function is negative 9. So any questions, just plug them into the Q&A box and our team will answer you. Yeah. I'll give you a second to copy it down. So I have a question whether or not if we plug in the value for the limit, if we plug in -7 and just imagine if we got 0 over 6. Now 0 over 6, so if we have something, if we plug in the limit initially and we get 0 over 6, 0 over 6 is just the same thing as 0. So it's not an indeterminate form. We can determine what the value of the limit is. If we have something like 6 over 0, then the limit would have to go to infinity. Now, positive infinity, negative infinity, depending on which. Positive, negative infinity. So 0 over 0 is a special case. Okay. So any other questions? We can move on. Yeah, we do have a lot of time for these 5 questions, so take your time, look it over, make sure you understand each step. Okay, so let's move on to question 2. So you should see question 2 on your screen. So we have to find the derivative of the function, but we can't do it using the power rule, which would be infinitely easier, but we have to use the definition of the derivative. Now, remembering what the definition looks like, it looks something like this. Limit as h approaches 0 of f of x plus h minus f of x over h. So it might be a little daunting to see this whole thing. I mean, there's a lot of steps involved. Instead of doing all at one time, we'll break it up into 4 different steps. So the 4 steps are as follows. The first thing we have to do is find f of x plus h. So how do we find f of x plus h? I do like to do a little example, like if we're trying to find f of 3, just imagine if our function now is f of x is equal to x squared plus 3. So f of 3, we would be plugging in 3 for each value of x. So that would be 3 squared plus 3, right? Which is the same thing as 9 plus 3, which is 12. But the point is, we're plugging in whatever's inside that parentheses for each value of our x. So that doesn't change when we're trying to find f of x plus h. All we're doing is plugging what's inside the parentheses, which is x plus h, into every value x in our function. So if f of x is equal to x squared plus 3, f of x plus h becomes x plus h, instead of our x, squared plus 3. So what's x plus h squared? X plus h times x plus h plus 3. I'll FOIL this out, so it'll be x times x times h times x, and h times h, which will give us the answer x squared plus xh plus xh plus h squared plus 3. I'll combine the like terms, so altogether it would be x squared plus 2hx. Yeah, xh plus 3. So that's our f of x plus h. So I'll circle it so it's clear. So that's equal to f of x plus h. That's our first step. Now, our second step is the second part of our numerator, which is subtracting our f of x. Now, our f of x is just our original function, and we're subtracting that from f of x plus h, which we've already found. So f of x plus h minus f of x is equal to f of x plus h, which is the function we did in step 1. So it's x squared plus 2xh plus h squared plus 3 minus f of x, which is our original function x squared plus 3. So any questions so far? Okay, so we'll simplify this, get rid of the parentheses. I'll multiply what the coefficient term is behind each parentheses. In this first term, in this first expression, the coefficient is just 1, so multiply everything by 1, everything stays the same. X squared plus 2xh plus h squared plus 3. In the second expression, there's a negative 1 behind the parentheses, so I'll distribute negative 1, and we'll get negative x squared minus 3. Our last and final step of this, of step 2, is to combine like terms. So I notice I have an x squared, cancels out with a negative x squared. A positive 3 cancels out with a negative 3. So all we're left with is 2xh plus h squared. Any questions? I'll circle that so it becomes clear. That's our result from step 2. Okay. So step 3 is finding all we did in step 2, f of x plus f of x plus h minus f of x all over h. So what we did in step 2, and just put that over h. So we have 2xh plus h squared. I'll write it so you know where it's coming from. F of x plus h minus f of x over h. So that was what we got from step 2, and this is all over h. Now we can simplify this by taking out the h, since both terms do have an h. So that'll be the factoring out h. So we'll take out h, and we'll be left with 2x plus h. So you notice that we have an h on the top, an h on the bottom, and that should cancel out. So the result from step 3 would just be 2x plus h. So just a word of advice. If you're doing the limit definition of the derivative, you should always cancel out the h. The h's should always cancel out. So if the h's don't cancel out, then you're definitely did not do it right. Okay, so the h's cancel out. Now we put it all together. So the final step is put the limit. So we have the limit as h approaches 0 of this whole thing, which just boils down to 2x plus h. I'll do the limit as h approaches 0, so I'll plug in 0 for h. So we'll have 2x plus 0, and that's just equal to 2x. So f prime of x is equal to 2x. Any questions? Now you can always double check your work, right? Because the original question was f of x is equal to x squared plus 3, and by this point you should know how to use, if f of x, this is just a side note, if f of x is equal to x squared plus 3, by now you should know your power rule. So finding the derivative of this should be easy. We bring the 2 down, we subtract 1 from the exponent, and the derivative of 3 is nothing, so this simplifies to 2x. So it's the same thing. We can use a power rule, we can use the definition of derivative, but the derivative is a derivative, so 2x. Answer is 2x. Yeah, in this problem, you're forced to do the definition, so you have to do all the steps. You can always check your answer using the power rule. Any questions? So feel free, if you got confused at any step of the process, to type into the Q&A box. We have a whole team here of qualified professionals to help you. So if there's any more questions, yeah, math angels, if you'd like to. All right, whatever. So question 3. We'll move on to question 3. All right. So question 3 says, given y is equal to f of x, y and f of x are sort of interchangeable, so is equal to x to the third minus 3x squared minus 5. Find the values of x where the tangent is horizontal. And write an equation for each of the horizontal tangent lines. So we need to find the values of x where the tangent lines are horizontal. Now, if you remember what the derivatives are, they're just the slopes of the tangent lines of the graph, of the function. And additionally, you need to remember also what the slopes of horizontal lines are, which are 0. So solving this problem requires us to finding the derivative of the function, then setting that derivative equal to 0. So let's do that using our power rule. So f of x is equal to x to the third minus 3x squared minus 5. The derivative of that function, using our power rule, we move the 3 down and subtract 1 from the exponents. So 3 minus 1. Move the 2 down, subtract 1 from the exponent, and the derivative of negative 5 is just 0. So this simplifies to 3x squared minus 6x. So that's our derivative. So now we have to find the derivative, and now we want to solve for x as we set it equal to 0. We want to set this equal to 0 because that's where the slopes of the tangent lines are horizontal. Slopes of horizontal lines are 0. So now let's solve for x. So we can factor 3x out of each term. So 3x squared divided by 3x is just x. 6x divided by 3x is 2. Now we set each factor equal to 0. So 3x is equal to 0, and x minus 2 is equal to 0. So I'll divide by 3. I'll divide by 3. So x is equal to 0. Wireless for a second. Okay, so let's continue where we left off. So we found our two values of x where our horizontal tangent lines occur. Now to find the equations of these tangent lines. So we can do y equals mx plus b to solve for the equation, but remember from your 119 and 110 class that the equations of horizontal lines are just y equals whatever the y value is. So all we have to do is find the y value at the given x values. I'll do that by plugging in back into the original equation our x values. So we need to find f of 0, which is equal to 0 to the third minus 3 times 0 squared minus 5. And we also need to find f of 2. We'll calculate this out. 0 minus 5 is equal to negative 5. Now we'll find f of 2. So plug in 2. We'll have 2 to the third minus 3 times 2 squared minus 5. We'll have 8 minus 3 times 4 minus 5. 8 minus 12 minus 5 is equal to negative 9. Yeah. So that was a lot of steps. Let's just go over what we did. So we had the original function f of x equals x to the third minus 3x squared minus 5. And I found the first derivative and set that equal to 0. I set that first derivative equal to 0 because we're trying to find the horizontal tangent lines, and the slopes of horizontal tangent lines will have to be 0. So set the first derivative equal to 0. So that gave us 3x squared minus 6x equals 0. We're right here, if you guys don't know. And I factored out 3x so I can solve for x. So I took out 3x, x minus 2 is left inside the parentheses, and then I set each factor equal to 0. So 3x is equal to 0, x minus 2 is equal to 0, and I solved for x for each. I got x equals 0 and x equals positive 2. So now we wanted to find the equations of the horizontal tangent lines, and we know that they occur at these 2 points where x equals 0 and x equals 2. We just need to find the y value. So the y value was found by plugging in 0 and 2 into our original equation. So we have 0, negative 5 as the point where the horizontal tangent lines occur, and also 2, negative 9. So any questions at this point? So we're almost done. We just haven't finished answering the question. The question was, what's the equation of the horizontal line that passes through these points? So the equation of the horizontal line is always y equals whatever y value that the point goes through. So for f of 0, the equation of the tangent line is y equals negative 5, and for where x equals 2, the equation of the horizontal tangent line is y equals negative 9. So these are our two answers. Any questions? So how do we know not to use y equals mx plus b? So we don't have to use the point slope form because you guys should know that the equation of a horizontal line is just y equals the y value because they're horizontal. I mean, if I asked you like to find the equation of the tangent line that goes through this point and has slope 2, then we would have to use the point slope formula. It's just because our tangent line is horizontal. So it makes the question a lot easier. So you understand what I did say to you? I mean, if you wanted to use y equals mx plus b, you could. I mean, y equals mx plus b, if you think about it, but what's the slope of our line? Now, the point is 0, -5, so if we plug in -5 for y, it's a horizontal line, so slope is 0. X is also 0, and we're just trying to find b, so -5 is actually equal to b. So plugging that back into y equals mx plus b, you have y equals -5. It's still the same thing. It's just you don't really have to go through that whole process every single time if it's a horizontal line that you're looking for. So any other questions? uh, so moving on, let's move on to question 4. 4a. So 4a, find dy dx for when y equals x to the fourth minus 9x plus 1 to the seventh. So we'd like to use it to find the derivative, so we'll have to use the chain rule. The way that I like to look at the chain rule is the derivative of the outside function times the derivative of the inside function. So y is equal to x to the fourth minus 9x plus 1 to the seventh, and we're trying to find dy dx. So I'll pull down the 7, just like I was using the power rule. 7 times x to the fourth minus 9x plus 1 to the 7 minus 1, which is just 6. So that's the derivative of the outside function. Now the derivative of the inside function is going to be 4x to the third minus 9. Yeah, so you guys will have to know what derivatives are. I mean, the first thing that you should know is the power rule, because that will come up numerous times. So power rule for derivatives, you bring down the exponent and then subtract 1 from the exponent. Any questions? Okay, so if there's no questions, we'll move on to question 4b. So question 4b has a radical, and I know how much everyone loves radicals. But don't get so intimidated. Question 4b is not too different from question 4a. We can make it look like question 4a. The one rule that you'll have to remember is that every radical can be expressed as a fractional exponent. So the cube root of 4x plus 1, we can say this is 4x plus 1 to the 1 over 3. So any questions on how I got that? So I didn't find the derivative just yet. I'm just changing the function into a form that I can use the power rule or the chain rule or whatever it is. So y is equal to 4x plus 1 to the 1/3. So y prime is equal to the chain rule, just like we did in question 4a. We'll bring down the exponent, multiply it by that, subtract 1 from 1/3, so I'll do this on the side, just in case you guys forgot your fraction rules. 1 to the third, 1 over 3 minus 1 is equal to 1 over 3 minus 1 over 1. Now we'll need the same denominators in order to subtract, so I'll multiply the top and bottom by 3. So we'll get negative 2 over 3. So the exponent here is negative 2 over 3. So that takes care of the derivative of the outside function. Now we have to find the derivative of the inside function. So the derivative of 4x plus 1 is just 4. The derivative of 4x is just 4, and the derivative of 1 is 0. So we're not really worried about that. So we can clean this up just a little bit, just in case you get bothered that doesn't look like the same answer in the back of your answer key. We can bring the 4 to the front and say 4 times 1 over 3 is just 4 over 3. 4x plus 1 to the negative 2 over 3. Okay. So the problem did say dy dx, and y prime is not the same notation, so to stay consistent with the problem, we'll leave it as dy dx. So if there's no questions, we'll move on to question 4c. So find dy dx for y equals cosine x squared minus 9x. So we'll have to do chain rule here as well. Derivative of the outside function times the derivative of the inside function. So dy dx is equal to the derivative of cosine, which is negative sine of whatever's in the inside, and that you have to know. If you get a little confused with derivatives of sine and cosine, I do have a little diagram here that helps me solve the derivatives. Like the derivative of sine x would equal cosine x, the derivative of cosine x would equal negative sine x, and the derivative of negative sine x is negative cosine x, and the derivative of negative cosine x goes back to sine x. So it goes full circle, finding the derivatives. But yeah, so if you want to find derivatives, you just go clockwise. So derivative of cosine x is negative sine x, negative sine of whatever's on the inside, and we're multiplying that by the derivative of the inside function, which is 2x minus 9. U subs. Okay. So we could do a U substitution to solve this problem. So our original problem was y equals cosine of x squared minus 9x. Now if we do a U substitution and say U is equal to x squared minus 9x, then y would just equal the cosine of U. So du is equal to 2x minus 9. So y prime is equal to negative sine of u du. So we substitute our u back and our du back, and we'll get negative sine of x squared minus 9x times du, which is 2x minus 9. So any questions? So both methods work if you would like. We can't use the product rule because it's not a product. Yeah. If you did use substitution in class for solving this problem, then that's how you should keep it. If you just did the straight up chain rule, then just do that. So the U substitution, what I did was I saw that cosine of x squared minus 9x is a little bit difficult to do, so I'll do a U substitution. I'll plug in U, I'll substitute U for x squared minus 9x. So U is equal to x squared minus 9x. The derivative of U is equal to 2x minus 9. So that gives us a new y, where y is equal to cosine of U. Now y prime is equal to negative sine of U times du. And we found out U and what du is, so we just put that in, plug that in. So here's our final answer. So show all work if possible. I think that, yeah, get as many points in as you can. I mean, that goes with any math class. With these problems, there's so many different steps that it's hard to memorize all of them, so you might as well demonstrate how far you know. So any other questions? We'll move on to question 4D. So question 4D, find dy dx, another derivative problem, of y equals e to the x times x to the third plus 4. So what do we notice about y? Yeah, so y is equal to e to the x times x to the third plus 4. This is a product. I mean, it's e to the x times x to the third plus 4. So we have to use the product rule when finding the derivative. So if y is equal to f times g, then y prime, or we'll use dy dx because they did use dy dx. dy dx is equal to f times g prime plus g times f prime. So we have y equals e to the x times x to the third plus 4. Now, before we go on, let's very clearly state what our f is, what our g is, what our f prime is, what our g prime is. So our f is our first term, we'll label that as e to the x. Our g is our second term, so this is x to the third plus 4. I'll write this off to the right. So f is equal to e to the x, g is equal to x to the third plus 4. So f prime, what's the derivative of e to the x? That's a special derivative, which is just e to the x. The derivative of e to the x is itself. G prime, we'll use our power rule. So the derivative of x to the third is just 3x squared. And derivative of 4 is 0, so we'll leave that out. Any questions so far? So dy dx is equal to f times g prime plus g times f prime. So f is e to the x, g prime is 3x squared. G is x to the third plus 4, and f prime is e to the x. So put it all together, it looks something like that. And that's it. So the answer in the back, just clean it up a little bit. I mean, we usually put the coefficient first. So 3e to the x, x squared, plus, so clean it up, 3x squared e to the x, plus e to the x to the third plus 4. So just clean it up a little. I mean, if you can't simplify and you can't clean it up, like, and that part really confuses you, leave it as, whatever you have. They test you on the calculus, not on the algebra. Oh, all right, scratch that. They test you on everything. Any questions? So any questions, just let me know. I'll go through it all again. Okay, so if there's no other questions, let's move on to question 4e. So if y is equal to x squared plus 3 over e to the x minus 9x, find dy dx. So what do you notice about y this time? It's something divided by something, or in other words, we can call that a quotient. So finding derivatives, we'll have to use the quotient rule. So let's reiterate what the quotient rule is. So if y is equal to f over g, then y prime is equal to g times f prime minus f times g prime all over g squared. So just like we did for the product rule, let's very clearly state what our f is, what our g is, what our f prime is, and what our g prime is. So I'll write this off to the side. So f is equal to our top function, x squared plus 3. G is equal to our bottom function, e to the x minus 9x. F prime is the derivative of x squared plus 3, which is just 2x. Derivative of g is going to be e to the x minus 9. So remember, the derivative of e to the x is a special derivative. It's just itself. So everyone with me so far, we can finish up the problem. So dy dx is equal to, let's follow the formula, g times f prime. So that's e to the x minus 9x times f prime, which is 2x. You subtract that from f times g prime all over g squared, which is e to the x minus 9x squared. So to stay consistent with the answer key, I'll move 2x to the front of e to the x minus 9x. So it'll be 2x times e to the x minus 9x minus x, x squared plus 3 times e to the x minus 9 all over g squared. So any questions so far? I'll give you a second to copy it down. If you have any questions while copying it down, feel free to ask. Okay, so if there's no questions anymore for 4e, move on to the next one, which is 4f. So given y is equal to f of x is equal to e to the x, determine the 100th derivative of y. So I guess we start this question by finding y prime. So y prime is equal to, well, if y is equal to e to the x, then y prime is equal to the same thing, e to the x. If we do the second derivative, is the derivative of the derivative, y double prime is e to the x. If we do the triple derivative, we'll get e to the x. I mean, you sort of see a pattern going on, right? It doesn't change. So, it doesn't matter if we find the 100th derivative or the 1000th derivative, y to the 100th, y prime 100 would equal e to the x. So that's our final answer. Well, 5e to the x is a different story, because it would just multiply over and over again. I'll just do this on the side real quick. If y is equal to 5e to the x, what's the derivative of... No, 5e to the x is actually the same thing. I'm sorry, I was thinking of e to the 5x. Yeah, y equals 5e to the x would be the same. So any other questions for 4f? So no... Okay, so let's move on to question 5a. Okay, we're trying to find the integral of 4x minus 3 from 2 to 5. So first thing I would do is separate the integral into two. Now we can do that. The integral of a sum is equal to the sum of the integrals. So we can split this up into integral of 4x dx minus integral of 3 dx. So we do each one separately, and we'll have to use the power rule for antiderivatives to do that. So integral of 4x, we would add 1 to the exponent and divide it by that number, which just simplifies to 4x squared over 2. Antiderivative of 3, or integral of 3, is just 3x. So I'll clean this up a little bit. I know 2 cancels out with 4, so we're left with 2x squared minus 3x, and that's our integral. Now we want this to be evaluated at the given limits of 2 and 5. The upper limit is 5 and the lower limit is 2. So we need to evaluate this. So we need to subtract the top limit by the bottom limit. So it's going to be 2 times 5 squared minus 3 times 5 minus 2 times 2 squared minus 3 times 2. So plugging in 5, and that'll be our first expression, and our second one will be plugging in 2, will be our second expression. So any questions so far? So let's evaluate. Exponents first. So 5 squared would be 25, so this would be 2 times 25 minus 3 times 5, which is 15. Exponents first, so 4, this will be 2 times 4 minus 6. Evaluate even further, 50 minus 35 minus 8 minus 6, 15. Sorry, I was jumping ahead. 50 minus 15 would be 35 minus 2. And our final answer will be 33. So any questions so far how I got that? There's a lot of steps, so if you're unclear on anything, just let me know. Well, how did I get 1 plus 1, 4 to the x, 4x to the 1 plus 1? So if we're trying to find antiderivatives, like we have derivatives, we have a power rule. If we have to find antiderivatives, we also have a power rule. So take, for example, if we're trying to integrate x squared dx, the integral of this would be the power rules. Sorry, power rule would state that we'd add 1 to the exponent and divide by that number, which gives us x to the third over 3 plus constancy. Now, if you did find the derivative of x to the third over 3, we would get back to x squared. So we would do our power rule here for derivatives. 3 times x squared over 3. So it is the antiderivative. So any other questions? Why aren't we putting the constant c, why aren't we adding c as we usually do for most integrals? Now the reason why we do that, we only add plus c for indefinite integrals. Now this particular problem is a definite integral, meaning that we have limits at which the integral goes through, so we don't need the plus c. So anything else? Okay, so let's move on to question 5b. So we have to find the antiderivatives for these three trigonometric functions. So we have the integral of cosine x plus sine x minus tan x, but we know that the integral of the sum is equal to the sum of the integrals, so we can break this up. So we'll break it up into the integral of cosine x dx plus the integral of sine x dx minus the integral of tan x dx. So let's start. What's the derivative? What's the antiderivative of cosine x? Uh, it's going to be sine x. And the antiderivative of cosine x is negative cosine x. And how about the integral of tangent x? Now, tangent x isn't so easy to do. We don't have, well, some people memorize what it is, but if you don't know, you can derive it, how to find the integral. So I would look at tangent x, and I know for a fact that one of the identities say that tangent x can be written as sine x over cosine x dx. So we would have to, how would we integrate? I noticed that the derivative of one of the terms inside our integral is also inside the integral. Like I know that the derivative of cosine x is sine x. So if that's the case, I can use u substitution. So I'll set u to the right, to the right. U is equal to cosine x, then du is equal to negative sine x dx. So I don't want negative sine x dx, I just want sine x dx, so I'll divide both sides by negative 1. In that case, we'll have negative du is equal to sine x dx. So you want a positive sine x dx because you want to replace everything in that integral in terms of u and du. Now, if you'd like, I can rewrite the equation as 1 over cosine x times sine x dx. Now, I'm not doing anything different to the problem except changing it around a little bit. So I notice that sine x dx is here. So sine x dx can be replaced with negative du. And 1 over cosine x, since cosine x is equal to u, we can write that as 1 over u. So it's 1 over u negative du. I don't like dealing with that negative 1, so I can move it to outside of the integral and have it as negative 1 over u du. Any questions so far? So just a reminder, we're just doing the integral of tan x dx. The integral of cosine x and the integral of sine x was easy if you remember your derivatives and integrals for those, antiderivatives for those. But tan x requires just a little bit more work. So integral of 1 over u du is just ln of u. So this becomes negative ln of u, which we can just rewrite. We want this in terms of x, not u, so I'll say this is negative ln of cosine x. Absolute value of cosine x. So put everything together. We have sine x minus cosine x minus ln of cosine x. Now remember, plus c. So I do have a question why um, this negative and negative become a positive. So if we move the coefficient -1 to the front, a negative times a negative is a positive. So that's why it becomes plus integral of 1 over u du. Any questions? Yeah. So the integral of tangent x should always be negative ln cosine x. So you can memorize that, but if you would like to derive it and show the work and demonstrate that, then you can. Yeah, if they give you something else to derive to, then it might not be so easy to memorize some of the other ones. You'll have to use substitution a lot of the time to solve. Okay, so let's move on to 5C, if there's no objections. Okay, find the integral of 5e to the x plus 10 over x plus 51. So again, I'll use a property that the integral of a sum is equal to the sum of the integrals, so I'll break down each separate integral. Break this into 3 separate integrals. 5e to the x dx plus integral of 10 over x dx plus integral of x to the 51 dx. So I want to clean this up a little bit. I don't really know what the integral of 5e to the x dx is, but I know for a fact that I can move the coefficient to the front. So we can have integral of 5 times the integral of e to the x dx. Same thing for the integral of 10 over x. I can write this as 10 times 1 over x dx. And I'll move that 10 to the front, but I'll do that on the next step. X to the 51, we can't really mess with, so we'll leave that as it is. So 5 times the integral of e to the x dx plus 10 times the integral of 1 over x dx plus x to the 51 dx. So I've changed it sufficiently enough that I can find the integrals just by looking at it. Now, 5 times the integral of e to the x. Now, the integral of e to the x is the antiderivative of e to the x, which is just e to the x. So, first term simplifies out to 5 times e to the x. Second term is 10 times the integral of 1 over x, and the antiderivative of 1 over x is ln of x. Ln absolute value of x. Now for x to the 51, it's a variable raised to an exponent, so we'll use our power rule for antiderivatives. So I will add 1 to our exponent and divide by that number. So my last line will just be cleaning everything up. So we'll have 5e to the x plus 10 ln of x plus x to the 52 over 52 plus c, since it is an indefinite integral. So any questions? I'll give you a second to copy it down. I can scroll up if you want to see the whole thing. A lot of steps. Yeah, with these kind of tests, you take them as slow as you can. The slower you go, the less mistakes you made, and you get to see sort of every little mistake, if there is any mistake, where you went wrong. So you can always go back and correct it. So let's go over the problem again. So what I did first was separate this into three separate integrals, because we can do that. The integral of a sum is equal to the sum of the integrals. So that splits up into integral of 5e to the x dx plus integral of 10 over x dx plus x to the 51 dx. Now we can move the coefficient to outside of the integral. I'll move the 5 out here. I can say this is 10 times 1 over x, and I'll move 10 to the outside here. X 51 we leave alone. Now the integral of 5 times the integral of e to the x, the integral of e to the x is just e to the x. So it becomes 5 times e to the x plus 10 times the integral of 1 over x, which is just ln of x. And the integral of 51 would be x to the 51 plus 1 over 1, which simplifies to x to the 52 over 52. So if there's any other questions, you just let me know. So one of the questions is, why did we move the coefficient outside of the integral? It's just one of the properties of integrals that we have to keep in mind. One of the properties that we do have is that if we have something, the integral of x plus y dx, we can break this up into integral of x dx plus the integral of y dx. We can also say if we have the integral of 5x dx, we can move the coefficient to the front. It's just one of the properties. So just imagine if there was a coefficient for the integral of x to the 51. So this is just side work. So imagine if we had 5x to the 51 dx. Now we can move the 5 over outside of the integral. 5 times x to the 51 dx. It just gives us one less thing to worry about when we're doing our integral. So the derivation of this comes from the product rule, so you can work it out from the product rule if you're feeling ambitious. But it is a long derivation, I think. Okay, so if there's no other questions, let's move on to 5D. So 5D actually is a lot simpler than 5C. We'll do the same rule, break it up into three separate integrals. So I'll say this is the integral of e to the x dx plus integral of 3x dx minus the integral of 15 dx. Now I'll do what I did earlier and move the coefficient to the front. And our last step would be just to integrate. So the integral of e to the x dx is just e to the x. The integral of x is just the power rule, so 3 times x to the 1 plus 1 over 1 plus 1 minus the integral of 15. So the integral of a constant is just 15, the constant times the variable at which you're integrating with respect the variable at which you're integrating with respect to. S plus the constant. But I'll clean it up a little bit. I'll simplify the middle term as 3x squared over 2 minus 15x. So that should be our final answer. Any questions? Thank you. Just a slip of the pen. Yeah, put the plus. There was a plus in front of 3. Slip of the pen. So since we came up a little early on time, so if you would like to look at any other question or would want me to explain anything else, 1 through 5, I can do that. So just let me know. Okay, so that concludes today's session. Oh, it doesn't conclude anything. We're not even close to done. Oh, okay. Sorry about that. So I'm looking at question 4E. Someone would like to look at. So 4E was a long one. 4E is the quotient rule. So first thing we do, I would list what the quotient rule is. g times f prime minus f times g prime all over g squared, provided that y is equal to f over g. So this is this. Erase the problem, do it again. Okay. So let's start it from the beginning. Okay, so let's start the problem again. Okay, so let's do this over again. Y is equal to a quotient, so we'll have to use the quotient rule. So if y is equal to f over g, then dy dx is equal to g times f prime minus f times g prime all over g squared. So that's just equal. So we just have to find out what our f is, what our g is, what our f prime is, and what our g prime is. So our f is our numerator, is our expression in the numerator, so we'll represent that as x squared plus 3. Our g is our expression in the denominator, which is e to the x minus 9x. F prime is the derivative of f, which is, using our power rule, 2x. And derivative of g prime would just be e to the x minus 9. So dy dx all together is equal to g times f prime e to the x minus 9x times 2x minus f times g prime all over g squared. So e to the x minus 9x squared. So that's our final answer. So we can simplify this, just clean it up so it looks like the answer key. And we have this. Okay, so is there any other questions that you guys would want to see? 5B, I got a request for. All right, I guess. Was it? Okay, so let's do 5B over again, since we do have the time. Boom. That did not work. I don't know how this thing. Okay. And then I'll just put cut. Oh, word. Sorry. Okay, so find the integral of cosine x plus sine x minus tangent x. So again, we can split this up into 3 separate integrals. I'll say this is cosine x dx plus integral of sine x dx minus the integral of tangent x dx. Okay, so let's integrate each one by one. So the integral of cosine x dx would be just sine x. Derivative of antiderivative of sine x is negative cosine x. And derivative of minus derivative of tangent x, which is a little bit difficult to do by itself, integral of tangent x. So we'll have to do a chain rule, u substitution. So we have the integral. I can make tangent x look like the integral of sine x over cosine x. Those are just one of the trig identities. And I'll do a u substitution. So I'll do a u substitution because I find the derivative of one of the terms in our integral also in our integral. Derivative of cosine x is equal to sine x. So I'll set u equal to cosine x. Du is equal to negative sine x dx. I'll rewrite my integral as 1 over cosine. So I'll rewrite my integral. Well, let's clean this up. I'll subtract my cosine. Make this minus cosine x. I'll rewrite my integral as 1 over cosine x times sine x dx. Now I want to replace sine x dx with du, but I can't because it's negative. So I'll divide both sides by negative 1. In that case, du is equal to negative du is equal to sine x dx. So now I can write this integral in terms of u. I can say this is 1 over u times negative du. Now negative 1 times du, it's a coefficient, so I can move that to the front. So this will actually be positive integral of 1 over u du. And what do we know about the integral of 1 over u du? It's a special integral, and the integral of that is equal to ln absolute value of u. But then again, we don't want this in terms of u, we want this in terms of x, so I'll replace my u back with what I originally substituted for. So it'll be ln of cosine, absolute value of cosine x. And that is our final answer, plus c. Any questions? So I have a question for 4D. So 4D, y is equal to e to the x times x to the third plus 4. So it's a product because it's e to the x times x to the third plus 4. So to find the derivative, we will have to use the product rule. So if y is equal to... Okay, so let's start it from the beginning and do it over. So if y is equal to a function f times a function g, we will have to use the product rule. So if y is equal to f times g, then y prime is equal to, or let's use dy dx because this question is in dy dx, as asking for dy dx. So dy dx is equal to f, whoops, is equal to f times g prime plus g times f prime. So from y equaling e to the x times x to the third plus 4, let's state what our f is and let's state what our g is, state what our f prime is, and state what our g prime is. So if f is equal to e to the x, g is equal to the x to the third plus 4. So f prime is equal to the derivative of e to the x, which is a special derivative. It's just e to the x. The derivative of x to the third plus 4 is going to equal 3x squared. Any questions so far? So using our product rule, dy dx is equal to f times g prime e to the x times 3x squared plus g times f prime, x to the third plus 4 times f prime, which is e to the x. And that's our final answer. If you want to clean it up so to make it look like the answer key, we can make this 3x squared e to the x plus e to the x times x to the third plus 4. So that will be our final answer. Any questions? Okay, so question for number 2. So given that f of x equals x squared plus 3, use the definition of the derivative or the four-step process to find f prime of x. So I'll do it all over again. Okay, so step 1, find f of x plus h. Now f of x plus h, we're just plugging in x plus h for each value of x. So our f of x was originally x squared plus 3. If I'm not mistaken. X squared plus 3. So f of x plus h would be x plus h squared plus 3, which is equal to x plus h times x plus h plus 3. And if we FOIL this out correctly, we'll get x squared plus xh plus xh plus h squared plus 3, where after we simplify like terms and combine like terms, we'll get x squared plus 2xh plus h squared plus 3. So this represents our f of x plus h. Step 1 done. Step 2, we're subtracting f of x, which is our original function, from f of x plus h. So x squared plus 2xh plus h squared plus 3 minus our original function, which is x squared plus 3. So keep in mind that we do have to parenthesize f of x. I mean, I do see a lot of students just leave it out and have that, but that's not correct because we're subtracting all of f of x, not just x squared. So parenthesize. That way it becomes x squared plus 2xh plus h squared plus 3 minus x squared minus 3.
I'll combine like terms, which in this case they cancel, x squared and negative x squared, positive 3 and negative 3, so we're left with 2xh plus h squared. Okay, so that's second step done. Third step, f of x plus h minus f of x, which is what we have in step 2, and we're dividing that by h. So we have 2xh plus h squared all over h. Now we notice on the top that we have h's in both terms, so I can factor out the h and have 2x plus h all over h. H's will cancel, so all we're left with is 2x plus h. Step 4, put it all together. So this was all the limit as h approaches 0. So we have limit as h approaches 0 of 2x plus h, which is equal to 2x plus, instead of h, I'll put 0, which simplifies to 2x. So f prime of x is equal to 2x. Any questions? Should we? Okay. So 4a and 4b, I had some questions on, so we'll go over those. Find dy dx for y equals x to the fourth minus 9x plus 1. So if y is equal to x to the fourth minus 9x plus 1 to the seventh, we have to use the chain rule. So the chain rule is the derivative of the outside function multiplied by the derivative of the inside function. So y is equal to x to the fourth, dy dx is equal to the derivative of the outside function. We'll bring down the 7, multiplied by that, and we'll have this to the sixth power, 7 minus 1 to the sixth, multiplied by the derivative of the inside function. Using our power rule, we'll have 4x to the third minus 9. Any questions? So 4b. So 4b is not too different from 4a. I would like to use the chain rule, but at this particular moment, I can't because it's in a radical. But I can change that radical to an exponent, fractional exponent. I can say this is 4x plus 1 to the 1/3. So now we can use chain rule. So same rules apply. Derivative of the outside function, I will put that 1/3 in front, multiplied by 4x plus 1. 1/3 minus 1 is negative 2/3. And multiply by the derivative of 4x plus 1, which in this case is just 4. So our answer is 4 over 3 times 4x plus 1 to the negative 2 over 3. Any questions? Question for 4c. So 4c is also a chain rule, but it's a chain rule with trig functions. So let's start from scratch. Oh, let's leave this up here because I like this. So dy dx is equal to the derivative of cosine x. So the derivative of cosine x is negative sine x using the diagram, but we have x squared minus 9x, so it'll be negative sign times negative sign of x squared minus 9x multiplied by the derivative of x squared minus 9x, which is 2x minus 9. That's it. If you want to do this by u substitution, you can also do that as well. So we can say y is equal to cosine of u, provided that u is equal to x squared minus 9x, and the derivative of u is equal to 2x minus 9. So dy dx is equal to negative cosine of u times du, which is equal to negative cosine of x squared minus 9x times 2x minus 9. Negative sign times 2x minus 9. So any questions? So if there's no other questions, 4f. So 4f is easy. If y is equal to e to the x, then the first derivative of e to the x is e to the x. It's a special derivative. The second derivative is the derivative of the first derivative, so it's e to the x. The third derivative is the derivative of the second derivative, and that's just e to the x. So you notice a pattern that no matter how far down you go, whether it's the 100th derivative or the 1000th derivative of e to the x, you'll always just get e to the x. It's a special function whose derivative is itself. All right, so let's redo 3. Okay. Okay. So let's go over 3, really slow. Okay. So given that the function is equal to x to the third minus 3x squared minus 5, find the values of x where the tangent line is horizontal. Write an equation for each of the horizontal tangent lines. Okay. So first step we have to do is to find what values of x where the tangent line is horizontal. So our derivative function gives us the slopes of the tangent lines of the function. So first step would be to find the derivative. So derivative of f of x is prime of x, which is 3x squared minus 6x using the power rule. So because our tangent line is horizontal, our slope is 0. So we set f prime equal to 0. So 0 is equal to 3x squared minus 6x. Does everyone understand up to that point? So what values of x satisfies this equation? We'll factor out 3x. I'll solve for x by factoring out 3x. We'll have x minus 2. And split this up into 2. So 3x is equal to 0. X minus 2 is equal to 0. So if you divide by 3, x is equal to 0. Add 2, x is equal to 2. So these are the values of x where the tangent is horizontal. Any questions? So these are the values of x where the tangent line is horizontal. We know where they are on the x-axis, but on the y we don't know. So that's why we plug these numbers into our original function to find the actual points at where the horizontal lines occur. So first thing I'll do is find f of 0. F of 0 is equal to 0 to the third minus 3 times 0 squared minus 5. 0 minus 0 minus 5 is equal to negative 5. So our horizontal tangent line occurs at 0, negative 5. So we'll do f of 2. Do the same thing for 2. So we'll have 2 to the third minus 3 times 2 squared minus 5. 8 minus 4 times 3 is 12. This will give us negative 9. So at 2, negative 9, that's where our second horizontal tangent line occurs. So we have to find the equations of these tangent lines. So if you remember that the equation of a horizontal tangent line is just y equals whatever the y value is at that point. So for horizontal tangent line, for equations for horizontal tangent lines, for horizontal lines are just passing through AB, passing through the point AB, the point AB will be y equals B. So in this case, you want to find the horizontal line passing through 0, negative 5, so that will be y equals negative 5. We're just taking the y value. And we have 2 points. We also have at y equals negative 9. So those are our 2 points. 2 equations of our horizontal lines. Me? Okay. So if there's no other questions, I'll give you 2 seconds. Okay, so if you guys missed anything, there's another review today at 1 o'clock at QCC, the Science Building, room 216, also known as the Math Center. and I am holding the review. So if you want to meet me, want to meet the voice behind the magic, then you can. And tomorrow we're going through 6 through 10 at 6 o'clock till 8 o'clock. So be there. Okay, so thank you guys for stopping by. I'll see you tomorrow. Or today, if you guys want to stop by. Alright, have a good afternoon.